Topic of the day, systems of inequalities. Systems of inequalities are just two inequalities on the same graph. The solution to a system of inequalities will be the area shaded by both or all of the inequalities. So let's give a couple of these a try. We're going to graph each one of them individually. I'll start with the y is less than or equal to 2x minus 5. I'll use red for that one. And we graph it like normal. Add -5 up to, do our slope of 2, downward. Get as many of these points as we can. That makes it easier to draw, even for me. And there we go. And that was going to be a solid line because it's less than or equal to. And since it is less than, it's shaded below. So we'll shade like normal. Shade the values we need to shade. Any value in that shaded area would work. For example, the ordered pair 8, 0 will work because 0 is less than or equal to 16 minus 5, which is 11, so that works. So we just do a quick check to make sure we've shaded correctly. And now we can look at the second one. The second one, which is 3x plus 2y less than 12. Let's go ahead and solve that. It's going to be 2y is less than negative 3x plus 12. And then when we divide by 2, we're going to get y is less than negative 3 halves x plus 6. We won't need to flip the inequality because it's we didn't divide by a negative. But we will need to remember that this is a less than, which means it's going to be a dashed line. So starting at 6, up 3 over 2, negative, like so. Get as many of those as we can. And then preferably use a straight edge and do what I just did, which is forget that it's a dash line. So go ahead and go back and do the dash line like so. And since this one's less than, it's going to be shaded to the bottom section or below. And then that means that our solution is the area that's going to be shaded by both. So it's going to be the area in here that's encompassed by both colors of shading. Now the key to remembering here is that the solution is what's, like I said, shaded by both. If we look closely here, it's pretty much all this area right in here. Now it's a horrible drawing of it, but you get the idea. What you do need to remember though is anything on this line, the red line that I drew, is going to be a solution. It is equal to the red line, but it's also shaded by blue. On the dash line, the blue border, the dash line, any point along that line will not be included because it's not part of the blue. So it's only, even on that line, it's only shaded by the red. The blue doesn't count. So anything that is in this area will be a solution. Anything in this area is only a solution for the red one. This area is only a solution for blue, and of course that area is not a solution for anything. For the second example, we'll do the same thing. We'll just do a quick graph of them. Y is greater than 2x minus 1. Remember, we graph by y-intercept, slope. That's usually the easiest way to go about doing it. This is a greater than, which means it's going to be a dashed line. And greater than meaning shaded above. Now, if you did pick up already, this is where you have to be very detailed when you graph. You can't sit there and just draw little half things. You need to make sure your line goes from side to side. If you only go like that far and then try to shade above it, that looks just kind of silly. So make sure your graphing is a lot more particular and specific here. All right, so let's look at the second one. Y is less than 4. That one has a slope of 0. So it's a horizontal line at 4. And it is also less than, which means it's another dashed line like this, except this time shaded below. Which then shows us that our solution is the area that is shaded by both, which will be all of this area in here. But this time, because both lines are dashed, neither one of the borders are actually part of the solution. So only the numbers inside that yellow area that are inside the two dashed lines will be the solution. And that is it. Inequalities, just graph them both, look for what they have in common, and be very detailed and organized and specific when you graph. Now go ahead and do the practice and make sure you check your answers. Always do a quick check to make sure your solutions work. by plugging them in. Even on this last one, I didn't do that already. But if I had, what I would have done is simply taken an ordered pair like, -6, 0, because that would be right here. It should work for both. And as you can see, the x is -6. That really wouldn't matter. The y is 0, so 0 is less than 4. That's true. Up at the top, 2 times -6 is -12. -12 minus 1 is -13, and -6 is greater than -13, so it works in both of them. Check your answers, move on.